I'm Thomas Sparks, Group 4 lead for Experiment 4, the air conditioner experiment, and give you a little bit of background information. Okay, so air conditioner, it's a heat pump. It takes heat and makes it go against its natural flow, hence the pump. They're reversible, so you don't have to have a heating and cooling thing in your house. And that's by the valve that we'll see in just a second. And the experiment goal is to perform a thermodynamic analysis on the AC unit. HVAC is a pretty big industry and a lot of mechanical engineers go into it. So it might come up in somebody's life in here. And also you just get to use an anemometer and a psychrometer, good practice because you might see that in the future. Okay, so how it works. It's working on the ideal refrigeration cycle. Well, that's what I'm basing my calculations off of. It's not actually going to be ideal. So start off with the compressor, and ignore these numbers here because they don't align with this. The compressor, it's going to be, we're going to assume that it's isentropic. Right along here. Then next we'll go through the condenser on this section here, and it's isobaric. The capillary tube is going to have expansion here. Now this is not isentropic like the compressor was because it's a throttling mechanism. So by definition, it's not isentropic. So this, if you look at 4 prime here, that would be if you were to introduce an isentropic turbine, and they don't do that because you'd be adding a whole lot of cost to your AC unit for basically no gain. And then finally, we'll go through the evaporator and back in the compressor. And here you have heat coming in and heating up, the heat from the low temperature area, heating it up there. And then finally, shoot. And then also, I just want you to know the reservoir. This is what we're going to use to change the amount of freon. It's around the capillary tubes, and these points where we're going to measure temperature and pressure. Okay, so procedure. Start off, we want to make sure the AC is off. Check to verify that the initial temperature and pressure readings are all the same for all 4. If they're not, we're going to have to do a little bit of calibration, but they should be the same. All right, then we're going to have the instructor turn on the AC, and then we're going to add as much freon to the system as possible by opening up the low pressure side valve and just getting as much freon in the system as possible. Then one group is going to use the psychrometer and the anemometer or the psychrometer. They're going to measure the dry bulb and wet bulb temperatures at the 4 points that I showed earlier, and then also they're going to use the anemometer to measure the velocity going in so that they can get a mass flow rate. Then we're going to record the pressure and temperature readings for that case, and then we're going to trade off between the 2 groups, draining the freon in half-pound increments. It's going to be a scale. It's going to be how you measure it. From 14 to 17 pounds in half-pound increments each time, measuring temperature and pressure. Then we're going to drain all the freon from the system as much as we can, and the other group will do the same measurements with the psychrometer and the anemometer as the first group did. And once again, we're going to measure the temperature and pressure. We'll repeat, this one, then turn off the heat pump. Okay, so this is my calculations for the COP. This is just assuming that going into the compressor you have saturated vapor, and coming out of the condenser you have a saturated liquid. You'll get these temperatures, entropy, pressures, and enthalpies. Here's your TS diagram, same one we showed earlier, and your pressure and enthalpy diagram, as you can see below you. So my predictions, based on the assumptions out of the lab manual, the pressure out of in the evaporator is 500 kilopascals, pressure in the condenser 1200 kilopascals. Use that to get those values I just showed you. Saturated liquid, like we talked about. And finally, the COP I got was 7.62, which I thought was pretty reasonable from listening to the groups that went previously. And finally, I just want to go back and talk about how the results will probably actually look, since it's not really going to be ideal. There'll actually be a little bit of a pressure drop here and here, and also here, due to friction in the compressor, it will go this way, although due to heat loss in the compressor, it'll probably end up on this side. And so that the heat loss in the compressor actually helps you out. And any questions?